So solving this system of equations, first making it into an augmented matrix, you would have the columns 2, 1, 5, 1, -1, -2, -3, 2, 3, and then the bar and the column 1, 1, and 6. And now you want to perform various row operations. Now the row operations you may have chosen to do might be different than what's being shown here because there's different choices you can make along the way. This one here, I did see a 1 in the first column that I would like to have up here in the position of 2, so I elected to just swap row 1 and row 2 to create this. So, that's an easy thing to do, and usually you can do such row swaps early on in these problems. It tends not to get done a whole lot later in the problem. So, if you could do a row swap to put a 1 into the position it needs to be put into, then by all means do it. Now that 1 is in the position that I want it to be in, I now want the 2 and the 5 here and here to now be put into zeros. And so I'm going to basically add -2 times this row 1, to row 2, and -5 times row 1 to row 3, or basically subtract 2 times row 1 and 5 times row 1 respectively from those rows. The rest of row 2 would be 3, -7, -1. The rest of row 3 would be 3, -7, +1. Now here, if you're looking carefully, you can already kind of see signs of perhaps a special case and maybe even a no solutions, because what you have here is you have the exact same variables, no x's, 3 y's, and -7 z's on the left hand side of the last two rows, but they're producing two different results. And since this is essentially still a linear function, it might be a three-dimensional linear function, you really should only have one output for each input. So having two different outcomes for the same combinations of x, y's, and z's already kind of leads you to that position. But if you don't notice it here, as you go through and perform a couple more steps, for instance, this needs to now be a 1 if I'm continuing to put this into row echelon form or reduced row echelon form. So I'm going to divide this row by 3 or multiply it by 1/3, and I would get 0, 1, -7/3, and -1/3 in row 2. The other two rows have been untouched. And then I want to get zeros in this position here and this position here. And so I'm going to take row 1 and add row 2 to it. That should make this become a 0. And I'm going to take row 3 and add -3 times row 2, or basically subtract 3 times row 2 from it to get a 0 here. And so when that happens, row 1 becomes 1, 0, -1/3, 2/3. So that becomes a 0. Everything else, this remained untouched, which it should, and these got changed accordingly. When the changes occurred down here, this stayed as 0 as it should have been. This became the 0 I wanted it to be, but this also became a 0, and this became a 2. So basically I have a row now that says no x's, no y's, no z's, or essentially nothing equals 2. That doesn't make any sense. That means that there is no solution to this system of equations. And so you can see that in the augmented matrices as well as you perform row operations. So it doesn't matter what method you use, you can still make the same conclusions, you just have to know what you're looking for. If this had been a row of zeros with a 0 over here, it'd be more inclined to have infinitely many solutions. And then oftentimes you're asked to write them in terms of each other. So you would say, okay, like, well, x equals x, and then you would maybe put y and z in terms of x, or you would say that z equals z and then put x and y in terms of z. It really depends on the results that happen and what gets canceled along the way. And usually, since you're following row operations like this, usually z is the last thing that gets canceled, so most things would tend to be put in terms of z. That is the end of this video. If you have any additional questions, please make sure to ask in class.